Now we know ideal case efficiency is 1 or 100%, and we have efficiency as MA upon VR. Okay. Now when efficiency is MA upon VR, what do you mean by that? And efficiency is 1. Therefore, you have MA equal to VR. Okay, this is in a ideal case. But MA will be less than VR in a practical machine. If a machine has MA value as 2, then its velocity ratio value will also be 2. Okay, but if the efficiency is not 100%, then MA will be the one which will always be less than VR. Okay, and you know that why. Look here. The numerator has to be less than the denominator for efficiency to be less than 1. So this is fulcrum, this is load, this is effort. And I told you that for class 1, if the fulcrum is exactly lying in between over here, then MA will be equal to 1. Okay, and that is what you know now is a directional advantage, okay, or change in direction. So that is a seesaw, okay, or something like a weighing scale, a physical balance. Now here there is a load and an effort, and if you have fulcrum over here, so over here MA will be less than 1 because you can see that the effort arm is longer than the the load arm is longer than the effort arm. So this is acting like a speed multiplier. And when you have the effort arm longer, that is when the fulcrum is over here, and then you have MA greater than 1, and this is because effort arm is longer than load arm. Now students, plier is used like a force multiplier. Now how is a plier acting like a force multiplier? This is fulcrum. Do you agree with that? Okay, that is where everything is going to turn. And this longer arm is the effort arm. Everyone clear with that? And this tiny one is the load arm. That is where the metal wire will be clamped and it will be cut using a plier. Now, since the effort arm is longer than the load arm, over here MA is greater than 1 and it acts like a force multiplier. This particular is the fulcrum, and the effort arm is usually smaller compared to the load arm. The load arm is the blades of the scissor, and effort arm is where you hold the scissor in your hand. And effort arm being smaller, okay, it acts like a gain in speed. So over here, students, what is happening is this lid is acting like a, and here the effort will be put down,
and that part the lever.
and this is a fulcrum, okay, where it is resting on the rim. So when the effort is put down, the load will be pushed up, and that is how it will be easier to open the lid. So this is also acting like a simple machine. Another example arm, okay. So this is the effort arm, which is longer, and the load arm is much shorter. So over here, MA will be greater than 1, and it will act like a force multiplier. Now, when this lady will push the lever, so that will be the effort, and the lever is resting over here, so that will be the fulcrum. And this lever is going to push the water behind, and that will be the load, and that will propel the boat ahead. So there are two types of rowing. I will show you the other one also. The other one will be class 3, but this is class 1 lever. Is this MA more than 1 or less than 1? MA is less than 1. As I said, I'll extend this over here. You have, this is the fulcrum, and the fulcrum will be here for this. And this person holding this in his hand, this will be the effort arm. Okay, and obviously this big will be the load arm. The load arm is longer, and we know what is MA, effort arm upon load arm, and therefore MA will be less than 1, and therefore this is gain in speed. This way of rowing helps them to row faster. So here the fulcrum will be at one end, load will be between, and effort will be here. So as I said that FLE. So class 1 fulcrum is in between, class 2 load is in between, class 3 effort will be in between. Okay, so here it is very evident that MA will be greater than 1 always, because effort arm is greater than load arm, always. The effort arm will be always greater than the load arm. Students remember, effort arm is effort to fulcrum, load arm is load to fulcrum. Okay. Of class 3 lever. In class 3 lever, the effort arm will be smaller than the load arm always, and therefore it acts like a speed multiplier. So this acts like a class 3 lever. A similar example would be of people who are sweeping the street with that long broom. If you can visualize that, the hand holding the top of the broom is not bearing the weight. It is just to turn it. Okay, if you try to do it with one hand, you will realize that the top hand, how important it is to give it a direction. The same thing in your house, if you have this to mop the floor, a longer rod with that cloth at the end to mop the floor. So this is how mopping also is done. The class 1, I want you to see the picture in the textbook, is of a person nodding his head. Of our head, the neck, these are the muscles which are keeping our head in, these are the muscles which are keeping our head in place. So that is the effort. Then class 2 lever, as you can see in that picture over there, it is standing on your toes. So if you think about when you stand on your toes, your calf muscles are strained. They bear the weight of your body, while the toes are helping you to go up and down, okay, the way you stand on your toes. So that acts like a fulcrum, while the weight of your body is between the effort and the fulcrum. So that is an example of class 2 lever. And the third picture in your textbook is class 3 lever. When you're holding a cup or anything in your hand, if you do that action, you will realize that your bicep muscles are getting tightened. So that is an example of class 3 lever.